Hi, I'm Olivia. I'm here at ACE HSC where I work as a maths tutor. Today I'm going to be taking you through a mechanics problem from a 4U HSC paper. And mechanics and forces tend to be one of the topics that students might struggle with a bit more because it's a little bit more like physics related compared to the other topics. But with a good understanding of how to do these types of questions, you should be good in no time. So first of all, first thing I always recommend students do is to start off by drawing a force diagram. So luckily they've already given us a diagram here for this question. So all we have to do is annotate. So we have a light string over a smooth pulley, and at the ends of the strings we have masses 9 kilograms and 5 kilograms. So they're each going to be experiencing two forces, which is the tension force and the weight force. So for both strings, the tension force is going to act upwards along the string, and really importantly, those tension forces are going to be equal because they're attached to the same string over a pulley. However, the weight forces are not going to be equal because weight force is given by W equals mg. So for the 9 kilogram mass, it's going to be 9g downwards, and for the 5 kilogram mass, it's going to be 5g downwards. That's our diagram of forces complete. The next thing that I would recommend doing is sort of thinking about what's actually happening in the system as a result of the forces that we're seeing. So because the 9 kilogram mass is heavier than the 5 kilogram mass, what we're going to see is the 9 kilogram mass is going to move downwards and the 5 kilogram mass is going to move upwards, right? So I'm going to add that onto the diagram. We have acceleration downwards for the 9 kilogram mass and upwards for the 5 kilogram mass. And then I'm going to define our direction of motion. So this is also something that tends to trip students up a bit, but we can basically define the direction of motion how we like, as long as it's consistent within our system. So for the 5 kilogram mass, I'm going to define it as upwards to keep acceleration positive. And for the 9 kilogram mass, I'm going to define our positive direction as downwards. Okay, our next step is going to be writing our equations of motion. So for the 9 kilogram mass, as always, we're going to have our net force is equal to mass times acceleration. And the net forces is going to be the sum of all the forces acting on the mass. So this is our weight force and our tension force. Because we've derived downwards as positive, our weight force is going to be positive and our tension force is going to be negative. So our net force is going to be W minus T. So putting all of that together, we have that 9 times our acceleration is going to be equal to 9g minus T. Okay, now for our 5 kilogram mass, we can take the same approach. Our net force is going to be equal to mass times acceleration. And we've defined upwards as positive now. So instead of being W minus T, like it was for the 9 kilogram mass, in this case, it's actually going to be T, which is acting upwards or positive, minus W, which is acting downwards or negative. So what that means is we have 5 times our acceleration is going to be equal to our tension minus 5g. So these are our two equations. And really importantly, this acceleration value is going to be the same for both masses because they're attached by the string, right? So whatever the acceleration of the 5 kilogram mass is upwards has to be equal to the acceleration of the 9 kilogram mass downwards. So all we have to do now is eliminate t from these equations to get a value for acceleration, which is what the question is asking for. So what we'll do is we'll just add these two equations together. So we have 9a plus 5a equals 9g minus t plus t minus 5g. And we can see that from there we can eliminate t from our equation. And what we're left with is 14a equals 4g. So a is 4 over 14g or 2 over 7g. So the acceleration of the 9 kilogram mass, our answer is going to be a, which is 2 over 7g. One final point for you guys to note is that acceleration is actually going to be for both the 9 kilogram mass and the 5 kilogram mass. Just for the 5 kilogram mass, it's going to be upwards and the 9 kilogram mass is going to be downwards. So that is how we would approach a question like that. Hopefully that all made sense. If you'd like to review mechanics as well as just other tricky questions in general, we'd highly recommend that you come check out our exam program, which starts at the beginning of July.